Let's see here. Did we do all of these already?
Yes.
Yeah.
Yeah? Right. I'd like you to go back to that study and go, I want to add a single term. It's called buffers. In study goal number 21, buffers. Buffers are like the edges on a clear cut where you leave a few trees standing either to protect water or to hide the clear cut from the road. Do you need paper or something? How much depends on it? Cuban? Buffers are like on number 23 today. Then we finish up like 25, 26, and we're out of here. First, I want to talk about trends in deforestation. There's a lot of details that kids get wrong. Please look up here at my map. Industrial deforestation, where people cut down forest which is more than for themselves, is, please look up here for lumber. There's a little bit more down in these mountains and a little bit more in New Zealand. But that's what we call temperate deciduous forest, those conifer forests that survive all the snow and then the snow melts and then they grow really fast and straight and tall. That's where all of our lumber comes from. Newsflash. Most of the deforestation that you hear about is here in the tropics, and that is not for lumber. There's very, very little lumber down there. Anybody want to help me build a list of 5 reasons why people cut down the forest in the tropics? Yeah?
Grazing.
Grazing is number 1. The number 1 use of tropical forest is so that the little sprouts can be eaten by livestock. The number 1 reason for tropical deforestation is grazing. For a few years there, McDonald's was the world's number 1 beneficiary of deforestation, because they used to buy a whole bunch of cheap cattle from Brazil. They don't anymore, by the way. Okay, if you're making a list of tropical deforestation, number 1 is grazing. Anybody want to guess the others? What?
Agriculture?
Yeah, plantation agriculture is number 2. Yeah.
Local people just eating it because they have nowhere else to feed them.
So, what we call encroachment deforestation, like sage is cold and needs to cut down some stuff, that's number, Dang, I'm blanking. It was ranching, farming, mining, logging. That's number 3. So number 3 is what we call encroachment deforestation or subsistence deforestation, where people need that stuff for firewood. And 4 and 5, maybe you heard me mumbling to myself. Mining is number 4, trying to access valuable metals and gems and stuff. And number 5 out of those 5 is the logs. There's very few valuable logs in tropical deforestation. Very few. Thanks for doing it. So in the tropics, deforestation is ranching, farming, firewood, mining, and logs. But increasingly increasingly, a bunch of forest is disappearing, and we don't even have to cut it down. Please look up, that's called indirect deforestation. That's when we do something that erases forest, but we don't even have to go to do it to the forest. The forest just dies on its own. Indirect deforestation. Did your book list reasons for indirect deforestation? So air pollution is a biggie. Water pollution is another biggie. And increasingly, climate change is affecting trees. I get to tell you today one of my favorite science nerd lectures. And I gotta warn you, this is a really nerdy concept. But if you're a nerd or you like being a nerd, this is gold. This is really useful. We've got a little bit of math and a little bit of biology and a little bit of environmental science mixed in. First, I just want to check in on something. How many of you have heard about the die-off of pine trees in western states, the pine beetle? You can see these around Bass Lake. You might have seen them around Mammoth Lakes, California. You may have heard about this happening in Colorado. The fact that a lot of our California fires are really bad because they're burning up this dried out forest that used to be green but has turned brown. How many of you have heard about this concept, this trend? There's a beetle that messes up pine trees. Okay. For those of you who haven't heard, it's okay, you don't live there. But in a lot of parts of western states, this pretty much starts in the Rockies and comes westward. A lot of conifer forest is dying, specifically pine forest is dying. Once all those trees die, they tend to die standing up. So all the needles turn brown, and you can see it from the road. You can see it from space. You can get like Google Maps imaging and see just big chunks of forest that's all turning brown. This is really visible around Mammoth Lakes, California, and around Bass Lake, California. Two areas where Santa Barbara people go to vacation a lot. For a couple of years, this was sort of mysterious. And for a couple of years, there was a lot of conflicting research. And in the last couple of years, it's become really, really, really clear. But it's so complicated that when people are just talking about it at the gas station, they get 2 or 3 words right, but they don't get the whole picture. You can show up at a party and be the interesting nerd. It's really a straightforward thing if you just get a few facts straight. You might need like a quarter page of notes for this. This is indirect deforestation in western states. It affects fires, it affects air quality, it affects costs. First thing you gotta know, there's this native, naturally occurring beetle. As a matter of fact, there's a bunch of different beetles. It's kind of a common life cycle for a bunch of beetles. There's even invasive beetles that do this. But they drill a hole into a tree, lay their eggs inside that hole, and then they back out, fly away, and die of old age. That's a great place to leave your eggs because the tree will heal that hole with a bunch of sap. You can see it because if you walk up to the tree, it'll have this big scab of dried up sap where the tree like bleeds out of that hole to plug the hole. In case you're curious, people call them pine beetles or boring, like a boring company, like to bore a hole. Boring beetles. There's an invasive one called the Asian longhorn beetle. There's a whole bunch of native ones. There's some that specialize in trees. Like my favorite is the alder hardwood borer because it's giant and it has these big obvious stripes. And their antennae are always longer than the body, so they're like graceful, beautiful bugs. Yeah?
How does it like destroy the tree though?
Well, the funny thing is that trees and beetles have shared the landscape since time immemorial.
Yeah, like why now are the trees getting...
And why now? Because of indirect deforestation, and I give you a really good explanation, and you're going to be the guy who gets it when nobody else does. We got to be clear, they're a natural stress on trees for millions of years now. All trees have them. Just like all of you have some germs on you that aren't killing you either. Are we good so far? All trees have them. They're all over the landscape. You'll never find an adult pine tree that didn't get 1 or 2 holes in them. Totally normal. Now, pine trees live on in a climate that's very particular. Conifers do okay with some freezing in the winter, and then they have some melting season to grow, and then they have the hard, dry out part of summer before the rain starts again. And in that same climate, beetles can move in, breed, grow, and die during the warm period, but they cannot survive the cold part. So beetles are only present during the warm half of the year, not during the cold half of the year. How many of you can see where this explanation is going? You want to try it out? Take over, go ahead. Yeah.
Slight climate change has made the seasons start at different times, so the beetles affect the pine trees a lot more.
Sure. You got some math to make this sound nerdier?
No.
Anybody else? Well, let's start with what you said so far. If we pick Mammoth Lakes, how many of you know Mammoth Lakes, California? Mammoth Mountain? June Lake? Okay. I'm not an expert on these dates, but I think I'm safe. I think I'm safe. That historically, the warm part of the year was like spring break, like mid-March/April. That's when the snow starts to melt and you really like spring conditions kick in. Let's say, as an average, like March 15 until November 1 is warm enough that the beetles could survive. But by November 1, snow sticks throughout the winter. Like things stay frozen. So I'm just making up the dates. If you want to correct me someday, correct me. It's kind of irrelevant. Please look up. For the sake of conversation, we'll say that temperature is too cold for the beetles from the 1st of November until the middle of March. And I don't know, that's what, like 4 months without beetles, 8 months with beetles. But climate change raises the average temperature at our latitude by about 1.5 degrees, give or take. I think at that elevation it's 1.6 or 1.7, I don't care, in the last 100 years. That does this, watch me. I'm just gonna raise this line up to have the exact same shape but I'm making it, 1.6 degrees higher. And what Sage said is, now correct me if I'm wrong, dude, when we raise the temperature a little tiny bit, it changes the season during which we get beetles. Because watch, instead of all of them freezing to death on November 1st, now they might make it until, I don't know, November 20th. And instead of the snow sticking until March 15, maybe now it's gone by President's Day sometimes. I'm pretty sure that that's wrong because the snow's usually pretty good President's Day in Mammoth. But actually last year it was bad President's Day. Isn't that right? Yeah. And my homie didn't go because President's Day was a bust already. They had spring conditions President's Day. I mean, look, I'm not an expert, so let's not bicker over these numbers, but the concept is right. Please look up. What I've done is, by heating up the planet a teeny little bit, I've let the beetles move into Mammoth 4 weeks earlier, and then I've let them stay in Mammoth like 3 weeks later. I want to give you all a hint, see if anybody wants to nerd out with me. Beetles reproduce exponential growth curve because they're insects, they make a whole lot of babies. It's not linear growth. It's not like another beetle every day. It's like every beetle makes 1,000 more every 3 weeks or whatever that is. So because they grow exponentially, can anybody nerd out for me what happens when their breeding season is longer?
The amount of holes just overwhelms the tree.
You're getting ahead of yourself. You're right. But let's baby step this for someone who's not good at math.
It has a chance to start growing faster and then keep growing when it's longer. Like it can still keep exponentially growing. So.
Anybody want to restate that, or can you say that again, maybe?
If it starts 4 weeks sooner, you have a bigger margin to start gaining more quickly, and when it's 3 weeks longer, you have more margin to keep going higher and higher, so there's just more and more beetles.
You were going to say?
Yeah, it's similar to that. When the cold starts later, there's more beetles, and so they can lay more eggs, so that when the warm months come back, there's more eggs than there were before, so it can start even faster, and then just it continues.
We're getting better survivorship from the previous year, and we're getting an extension of exponential growth when the growth curve is already at the steep part. You understand what I mean by that? Like, exponential growth at the shallow part is really gradual, but we start that a couple weeks earlier, and then instead of knocking them back here, you give them 7 more weeks to keep going, and that population will be hundreds of times historical averages because it's growing at the steep part of the J curve, at the exponential part of the J curve. What's happening is trees are dying from an abundance of paper cuts. As a horrible coincidence, climate change in the western United States means more drought. So they're already dried out because of drought. By the way, drought can also be independent of climate change. It appears that the western states have a drought cycle. So we have a drought cycle which is independent of climate change, and then our drought is worse due to climate change because western states, position of the jet stream, temperature differential of the ocean and land, okay? So we have drought, plus climate change makes the drought worse, plus climate change makes a lot more beetles. And all these trees could deal with a little drought, and they could deal with a little summer, and they could deal with a few beetles, but not when you crank up all that at once. Longer, hotter summer with worse, drier droughts, and an unbelievable abundance of those beetles. I've seen trees that look like they have a donut of sap around the base. Because instead of 1 or 2 holes, they'll have 1,000. That's like dying of paper cuts. Like just, it's like so much sap loss that they can't even feed their leaves, and that's why they dry out. Like the trees are literally dried standing. They turn brown, like an old Christmas tree. Your notes have to say, beetles are normal, they drill the holes, they lay the eggs, the babies come out in their own holes. Easy. Trees can usually heal. Your notes should definitely say a little bit of warming. It's just 1 or 2 degrees. It's not a lot. Like the trees don't die from the heat, that's for sure. But a little bit of warming affects the different seasons. The die-off is really short. The breeding season is longer. So beetle populations are like overwhelming year after year after year after year. These forests have 1,000 times more beetles. Sometimes just like masses of beetles. That's what happened at Bass Lake. They've had winters with no snow. So now there's just like, the beetles have like a 2-year breeding season.
Where'd they go?
If I'm not mistaken, they die, and so they will repopulate from lower elevations uphill. So they kind of follow the thaw line in the spring.
Just where like their eggs are laid, I guess then?
Right, and so some of those, when they fly away, the storms will blow them out of the mountains, and they overwinter in an environment without pine trees, and then they kind of climb back up. Maybe they have residual populations in pockets that don't. I don't know. That's a good question. Do y'all like that nerdiness? How like a little bit of climate change and like a little bit of seasonality and a little bit of plant biology and a little bit of math comes together to this like crazy mystery problem? Like now our fires are worse. Now the trees don't grow anymore, so they don't absorb carbon anymore, and then when they burn, they release a whole bunch of carbon. Like this has like huge implications on your state, and you get it. Like you don't have to be a genius. You can be 17 and just starting to be human. I don't want to do 25, 26. Because we only have a few minutes and then all the other classes haven't done it yet. First, questions on my bad graph, my temperatures, my beetles. Yeah?
Are they able to do anything to help prevent it?
So dude, it seems right now like the best thing we can do is light those forests on fire to try to keep the populations of beetle in check. But of course, big wildfires and dry forest doesn't sound good either. So it really, like, most of the forest nerds that I know up in the Sierra, they've kind of, the community belief is that we will no longer have pine forest. Like, it'll just be a matter of time before other trees start growing there, you know, like some other tree will like these conditions. And so it's probably like a long-term diversity shift. You know, we're going to see the localized extinction of conifers through most of the western states at most elevations. You'll probably still have them at like 8,000, 9,000 because the beetles still don't get a long enough season there. So all that middle elevation pine forest is just going to become oak scrubland or something.
It's like the Bay Area.
over a few generations. What?
Like the Bay Area.
I guess, yeah. Yeah.
What happens if, like, what are the, I forget the word for it, but what happens if you, like, just kill all the beetles?
Well, exterminate? Is that the word
What
you're
are,
looking
like,
for?
what are the defects? What are the defects of killing all the beetles?
Well, I mean, I don't know if they have any particular secret connections that are especially critical. You only find the keystone species when they're gone. So for all I know, they have some other part of their life cycle that's important, and I don't know what that is.
Yeah, like when they leave, maybe they.
So I'm not sure. They must have some way to survive the winter because they're naturally present in the spring. I see them myself with my own 2 eyes. I literally caught one in my hand this year in June in southern Yosemite. I don't know. I can't understand if you. I'm not sure which question I'm answering. I think if you killed them, that would probably benefit the trees. Separately, I really don't know a viable way to kill off any insect at the landscape level. You know what I'm saying? Like, that doesn't seem. And then separately, like, who knows? Maybe they're like an important food source connected to some other thing that's connected to an endangered bird, and we might have shot ourselves in the foot with that. I don't know.
Well, you'd think if there was something like that, then wouldn't the population go up of that bird or something like that? If there's just
So the problem with trying to predict these ripple effects
there's just no way.
is that whole thing about we're living in the experiment. We don't get to do. We just find out when it happens. Like that. That's the problem with environmental science. Like all you can do is like figure out what's happening, not really predict what will happen. It's tough to model that. I don't know what the beetles would do. What else? Abby, you want to stop streaming? Thank you. Okay.